you need to be able to do it very fast because you want to reduce the price to a minimum, of course.
Okay, and this is where you would do the welding.
Correct.
Okay, and how do you do the welding, if I may ask? Like you get in between there and weld.
Yes, yes. So yeah, a common strategy is laser welding, of course. We can also look on some pictures here.
Yeah.
First of all, of course, it's a very hard job to weld 50 microns times 50 microns together because there is no material actually on the plate that you can use for any for any weld. The companies are actually doing that very, very good on the market.
Yeah.
The task today is to be very process reliable because the welding itself can destroy the plates. You can cause some defects on the plate.
Okay.
And you need to be able to do it very fast because you want to reduce the price to a minimum, of course.
Okay. Okay. So looking at this diagram here, what do we see here? I mean, I recognize the channels.
Yes.
Again.
So we're only seeing a little bit of the plate. So only 2 channels. We're talking about 2 or 3 millimeters here.
Yeah.
And the dots in the bottom of the channel are actually the laser welding dots. And that is some kind of 3D deep measuring we're doing here in order to look on the weld seam, in order to look on the weld dots, because you not only need to weld the plate around, because you need, of course, a leakage weld for the coolant channel.
Yes.
You also need some electrical contact welding in the flow field. That is also very, very crucial for the functionality of the plate, because a lot of energy needs to run through the plates.
When I think of that, that's the especially a plate at the end essentially is taking up the entire. Actually, all plates are taking up.
Correct. So they're aligned in line. So you have one big anode at the top of the stack and one big cathode on the bottom of the stack. And a lot of energy needs to run through
all
those
the
plates.
cells need to transfer all that what's being generated. Okay.
And that is why the plates needs to be in the best shape possible. Because any deviation is causing some energy loss. Yeah. Because the contact is not as the engineers of the stack originally thought of, and that is why theory and practical implementation are laying far from behind.
Okay, Simon, I need to ask it. So I mean, I've just idealized how these plates lie on each other, and I know you make these, and then you for the bigger stack.